Hey guys, so last lesson for this week, 2.7, driving and risk. So this is dealing with the amount males, females that have been in an accident or haven't been in an accident, those who have cars, those who have motorcycles, and just figuring out, all right, well, what's the safer, maybe safer gender, safer mode of transportation, and all this stuff is still falling under that category of probability. So here we go. First problem, Javier will be a high school senior next year. He wants to get a vehicle to celebrate his graduation. Javier's mother researched vehicle safety, found that 1 in every 6 teenage drivers are involved in some kind of accident. So 1 out of every 6 teenage drivers led them to think, all right, well, what is the risk here? So Javier decided to survey 500 students at his school. 230 were male, and then you have those that he's saying, look, I want to get a car, or I want to get a motorcycle. No student in this specific scenario has a car and a motorcycle. I know that's possible, but in this scenario, we're saying that it's not going to fall under that category. All right, so we see that the results of the survey are telling us, we know the number of males, first of all, was 230. So we can find the number of females, kind of like that two-handed backswing problem we had a few lessons ago. So we can look at this and see, okay, well, then the number of females would be 270 females. And then we were told the number of males in the survey. So that gives us a general idea of how to find those that maybe don't have either a motorcycle or a car. So we know that there's 150 males with a car. There's 23 males that have a motorcycle, so that is 173. So if there was 230 males, and we're saying 173 of those males have that 57 do not have a vehicle. So this is our males. So I should say, I guess, males do not have a vehicle. All right, and we can do the same general thing with the females. So 270 females. And we've got 225, so 235. 235. That leaves us with 35 that do not have a vehicle. And again, this is your females for this part. All right, so again, we can add that. All right, so if we've got our females, that do not have a vehicle, the males that do not have a vehicle, and then we can add up all this, the rows. We can do that pretty straightforward here. So this would be 46 total males involved in an accident, 19 total females involved in an accident. So that gives us some good indicators of what our totals are. I guess males, we know 230, females were 270. That was our totals. And we have the number without a vehicle. So when it says draw a Venn diagram, kind of like what we've seen in 2.6, where we saw a Venn diagram, it can be helpful where you have it, but when you start overlapping a bunch of circles in your Venn diagram, the data gets just a little confusing. So I recommend the tree diagram out of the two. So I mean, you can see 57 do not have a vehicle. So we'd have that amount there. We'd have our 127. When we subtract to get our total, we could have our 46. We could have our 216 with a vehicle. When we subtract them all out, we can have our 19. Then we can start getting into those that don't have a vehicle for the females on the outside. Again, it just starts getting a little muddled up. So I would say just, if you want to get that down, you can. I'm not going to necessarily look for it for that particular one, but I'll look at the tree diagrams. So with your tree diagram, this is where it's very similar to what we saw with our stocks and risks, in that we'll be dividing and kind of going back and forth looking at the chart. So I'll kind of just put up some of that information with the chart so we don't have to scroll too much. But we can see that we have males and we have females. So those are our two genders. Then from there, we would want to take our total of people surveyed, and the total number of people surveyed was 500. So we know that we have a total of 230 males. So just right there, right here, 230, and we divide that by the 500. And then the females, we have 270, and divide that by the 500. So that would give us 0.46 when we divide those, as far as the males go. And then in turn, what makes up the rest would be our 0.54 females, so 46%. Then we branch off to have our different categories here. So for our different categories, 3 groups: those with a car, those that don't have either one, so we'll just say neither, and those that have a motorcycle. There you go. All right, and when we break those up, we're going to be just dealing with the males. So there's 230, so we get our categories from above. So 150 of the students up above for males had a car. Neither, we had to kind of subtract that out and find the neither, so that was 57 for males. Yep, all right, 57 out of the 230. And then the motorcycle was given up above, and that was 23. All right, so all these are out of the total number of males. So I divided that, then we can continue on with cars. And we could say those that have been in an accident, so accident, and those that have not. So we'll just say not. So we continue, those that had cars, there was 150, so now our total here would be 150. And then those that have not would also be out of 150. And we said that 40 have been in an accident in a car. So that means when we divide that out, we would get 0.27 that have been in an accident. So what that means is 110 people have not, or I shouldn't say people, it's 110 males that drive a car, have not been in an accident, and so that would be the other remaining 0.73. And we don't know anything about the neithers. We're assuming that they haven't been in an accident behind the wheel anyways. We can't initially get into passenger accidents. And so we would say, well, we had 23 people that have a motorcycle, or 23 males with a motorcycle. So with our 23 males, we would see the number of accidents was 6. So that in turn leaves us with 17 that had not been in an accident. So that gives us 0.26 that had been in an accident, 0.74 that had not been in an accident. So that's all our males. We'll do pretty much the same thing with our females. So we'll put this. So as we're putting that up there, we see that the females are at a 270. So we get each of our categories, the 225, 35, and 10 for our various cars, motorcycle, or neither. So that would give us 0.83, being the largest group was females that drive a car. Neither, when we divide that, that's 0.13, and then we divide by 10, so let's see, that's 86, 96, so 0.04 would be the amount, rounds out to give us 100. Then we're getting a little tight here, so I'll kind of start doing it like this, and like that. All right, so this would be those that have been in an accident, and then no accident, accident, no accident, accident, no accident. So we narrow it down out of the number on top, because now there's 225 females that have a car, and out of those 225, we have 15 that have been in an accident. And then all right, so I filled out the rest there. So that gives us the number of females that drive a car that have been in an accident and haven't been in an accident, and the number of females that have a motorcycle and have been and haven't been in an accident. So that gives us everything we need as we start to answer the questions. So using the data, what's the probability that Javier will be involved in an accident if he gets a motorcycle? So we would say, all right, well, Javier is male with a motorcycle. So male with motorcycle, and it's asking what's the likelihood of being in an accident. So when we go through our lines here, we have 0.46 was our male, 0.10 would be those with motorcycle that have been in an accident. So that one, we multiply all that out, that gives us 0.01, or 1% chance. So if he's going to his mom with that information, that's a pretty good way to present the argument that, all right, you see that if I get a motorcycle, the likelihood of the males at my school with motorcycles who have been in an accident is 1%. So that's a pretty good argument there. All right, based on the survey data, Javier told his mother that he only had 1% chance of getting into an accident. Is he correct? And so we look and we say, did he solve all this correctly? And as we're looking, you would say, well, it looks like all the math is right, but he forgot to factor in all the males that got in an accident who had cars, because it could still happen that he could potentially need that information here because he's going to his mother about getting a vehicle, not just a motorcycle. So we would have to take in the number of cars and do the same thing. So with the cars, you have 0.46 male, you have 0.65 that are driving a car in the survey, 0.27 that have been in accidents. We multiply all that out and we have 0.08 or 8% for the cars. So if he's just looking for a vehicle and saying, look, this is the likelihood, then now we would take the 1% plus the 8%, and it would be 9% likelihood that as a male at his school that he would get in an accident. So almost 1 out of 10 is kind of what we're looking at there. All right, using your Venn diagram from the beginning or your tree diagram, you're going to write 3 facts that will help Javier convince his mother to let him go. And again, you could pick really any 3. When I say go get a vehicle or have a vehicle, you could say. So we would say, all right, well, we know that there's 500 people surveyed and 435 did not get into an accident. So you could say the likelihood's pretty high that I'm not going to get into an accident. All right, 127 males with a vehicle did not have an accident. And then you could say only 46 males out of the 500 people surveyed were in an accident. And again, this, you could pick all kinds of things that you want. It really doesn't. And you can go off the tree diagram to get specific, points, data, where you say here's the percentages, or you could go off just the sheer numbers. All right, what probability model would you advise Javier to use when he's trying to convince his mother? I would definitely, in my opinion, use the tree diagram. But you could, for number 5, I wouldn't mark it wrong if you could make a convincing argument for a Venn diagram as well. But the tree diagram, you get all the specific percentages, and it's really beneficial. So I'm going to write tree diagram. If you write something else and you can validate it, no worries there. All right, guys, as always, just reach out if you have any questions, and I am here to help.